With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that consider a uniform wire of length L cross-sectional area A, Young modulus of the material is Y. Now some information is related to the wire is given in column 1 and the dependence of the result is given in column 2. We need to match the column 1 with the column 2. Now the first part is given that let us suspend wire vertically from a rigid support and attach a mass M at the lower end. Now, if the mass is slightly pulled down and released, it executes SHM of time period T, which will depend upon what? Now, if we just represent our situation, let's say this is our fixed end to which we have attached, this is our wire and to which we have attached a mass. Now, if we stretch it by an amount X, so what is the force required? Let's say Young modulus of the material is Y. So we know that force which would be developed, this would be equals to Y Y. So we just write, first of all, we just write the equation. We know that stress upon strain, this is equals to Young modulus. Now stress could be written as force per unit area, okay, and the strain could be written as elongation divided by the length. This would be equals to Y. Now the force would be written as capital A is the area, so we can just write force to be equals to Y AX divided by L. Now this force could be written as, because we know that it would be directed opposite, okay, in the opposite direction it would try to pull this back into the original position, so it would be executing SHM. Force could be written as mass into acceleration. Now from this expression we can see that our value of X divided by A would turn out to be ML divided by AY. Now how is the time period given? Time period is 2 pi under root X divided by A. Now if we know the ratio of X by A, we can directly get the time period, so it would be 2 pi under root ML divided by AY. That means time period depends upon length, area, and Young modulus. So length, then area and Young modulus. So we can say that the correspondingly the correct option we are writing with the red, P, then R, then S. Now for the second part, the work done in stretching the wire up to a length of L plus X would depend on. Now this is a simple. So for our B, we know that work done would be, if we want to calculate the work done, it would be F dot dx. Okay. Now the initial, we are stretching from L, so initially length would be L to L plus X. Okay, so what would be the limit of the stretch? So initially there won't be any stretch, and finally what is the stretch? It would be equals to X. Now what would be the value of force? We know that force value is this, so we can just put the value of force YX divided by L multiplied by dx, and we can integrate it from 0 to X. Now if we integrate this, then work done would turn out to be YA divided by L. So these terms are the constant. We can just integrate it, so it would be X squared divided by 2. That means it depends on Young modulus, area, length, and this X. So we can say that the correct option for this part would be P. For B we are just writing, so P, then Q, then R, then S. On all the factor it would depend. Now in the third option, if the given is fixed, is fixed between two rigid support and the temperature is decreased, we need to find what is the thermal stress. Now in the C part, we know that the strain which is developed, strain due to the thermal, we say that due to the thermal stresses, the strain which is developed is equals to alpha into delta T. Okay, this is the strain. Now we know that stress upon strain is equals to Young modulus. So we can say that stress which is developed would be equals to Young modulus time alpha delta T, where alpha is the coefficient of linear expansion, delta T is the change in time. Now here coefficient of linear expansion and time, these are not given in the column 2. Only the material property of the Young modulus is given. So for the C, the correct option would be the P. Now for the D, if we see, the wire is pulled at its equal end and the opposite force of the magnitude F, so that it undergoes an elongation X, which is given by Hooke's law as Kx. We need to find the force constant K depends on what? Now in the D, now force is given as to be what? It is given as to be K into X. Now from the, here we have already derived the force expression, which is YAX divided by L in terms of the parameters, the property of the material. So YAX divided by L. Now if we compare these two, we can get the value of K to be YA divided by L. That means K depends on Young modulus, area, and length. Now if we check for the option, so K would depend on Young modulus, that means P, then area and length, that means R and S. So these are the correct. So for A, PRS, for B, PQRS, for C, P, for D, PRS. Hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level, Trusted by more than 5 crore students. Download Doubtnut app today.